Here are your class notes for sections 1.5 and 1.6, and these notes should go on the class notes side of the reading notes chart you already made. If you did it all as one chart, then just put the 1.5 stuff next to the 1.5 stuff and the 1.6 next to it, or if it's two separate charts, I'll tell you when to switch over. So 1.5 was about the shortcomings of volume as a measurement of matter. And the main idea there is just that volume's not always the best way to measure the amount of something. And there are certain situations in which it's not the best way. So one is granular substances like sand, and that's because of the air spaces. That's what we found when we did our sand lab. We found that somewhere between 1/3 and 1/2 of the sand is really just air. So if you're measuring something that is a solid, but it's granular, volume's not the best way because there's so much air in it. There are going to be 4 more examples, so make sure that you write down all 4. Another example is gases, and that's because they can compress and expand, and you might have this in your reading notes already. So when you put more air into your bicycle tire, the tire's volume doesn't change that much, but you're putting a lot more air into it. So because of that, it's not the best way. Another good example is there are certain substances that dramatically change their volume with temperature. When things get hotter, the molecules move faster, so they move farther apart from each other, and so it expands. And this is how a thermometer works. When you heat up the liquid inside the thermometer, it expands, and that's why it goes up the thermometer. So volume's not a great way to measure those substances because the volume would change dramatically with temperature. Another example is a phase change, like water to ice. When water turns into ice, the volume changes. It expands, that's why ice floats in water like in the picture here. So volume's not the best way to measure. And then finally, the last example is one substance dissolving in another. And this specific example was in your book, so it probably is on your reading notes side as well. So what the picture here shows is the left tube for comparison shows you what the original volume was. And it's just water, but it's just there for comparison. So if you mixed salt into the water in this test tube, the top line shows the original volume with water and salt together. And that's with water filling in all of the spaces in the salt. But after the salt dissolves, you'll notice the volume has gone down. So when one substance dissolves in another, the volume changes. And so that means volume's not the best way to measure the amount for that either. So for these certain situations, volume's not sufficient. And that's why we need another way to measure things, and that's where mass comes into. So certain things we'll measure by their volume, and other things we'll measure by their mass, and it depends on the situation. So here's what mass is. Here are your notes on mass. Mass is the amount of matter in something. And mass doesn't depend on shape. It doesn't depend on temperature. It doesn't depend on a lot of the things that volume could be affected by. All that matters for mass is how much stuff there is in an object. There are 3 tools that we're going to use to measure mass. The first one is the equal arm balance, and we'll do a lab with the equal arm balance next week. And the way the equal arm balance works is you put known mass on one side, and then you put the object you're massing on the other side, and you figure out what the mass is when the balance is exactly horizontal. So this is the most low tech, but it really gives you the best idea of what you're doing when you measure mass. You're measuring literally the amount of something compared to a known mass. In order to be more precise, Often you use an unequal arm balance instead. You may have heard of something called the triple beam balance, which is an example of the unequal arm balance. And that triple beam balance is the picture in the middle. So instead of having another pan on the other side, the unequal arm balance has these little sliders that you can move. When you move those sliders, it balances, and that tells you what the mass is. When you go to the doctor's office, a lot of the time they'll weigh you on an unequal arm balance. That's the one on the right. So you stand on it and they move the sliders, and that's how they tell what your mass is. And then the final one is the electronic balance. So when you put your object on the electronic balance and it magically tells you what the mass is, it's been calibrated so that it tells you the mass, just like an unequal arm or an equal arm balance would. In this class, we're going to use the electronic balance most of the time, but know that what you're really doing when you put something on that balance is you're comparing it to known masses that are stored in the computer of that balance. And so it does the same thing that the equal arm balance does. All right, that's it for Notes on Mass. Have a good one.